Hello everyone, myself Dr. Padmaja, Associate Professor, Department of CAC, Institute of Aeronautical Engineering, Hyderabad. In this video, we are going to discuss about problem solving using stacks. Now, let us start with the first problem using stack. Now, as you are aware, stack is a linear data structure where there are two basic operations, push and pop, where push is used to insert an element to the stack, where pop is used to remove an element from the stack. Now, using the concept of stack, we can solve a variety of problems. So, let us start with the first problem. Now, the first problem is evaluate a reverse polish notation. Now, arithmetic expressions can be solved using the stack. Now, arithmetic expressions are basically of three types. One is called infix expression, prefix and postfix expression. Now, out of these three types of expressions, your postfix expression is also known as reverse polish notation. Now, how to solve a postfix expression or reverse polish notation using stack concept, let us understand through this problem. Now, you are given an array of strings tokens that represents an arithmetic expression in a reverse polish notation. Evaluate the expression, return an integer that represents the value of the expression. That means in this question, you have been given a list of strings and you have to evaluate that reverse polish notation, which is given in the form of list of strings, and you have to return an integer which is nothing but the value of the reverse polish expression. Now, there is a note that the valid operators are plus, minus, multiplication and division. So, there are four valid operations they have considered in this problem. Each operand may be an integer or another expression. The division between two integers always truncate towards 0. That means you have to do integer division over here. There will not be any division by 0 errors. The input represents a valid arithmetic expression in reverse polish notation, and the answer and all the intermediate calculation can be represented by a 32-bit integer. So, these are some specifications that we have to follow while solving this problem. Now, let us start with the test case. So, if our token is 2, 1, plus 3 and star, okay, then what is, suppose it is 2, 1 plus 3 star. So, you can see that this can be added like this because it is in the form of AB plus. So, it will be 2 plus 1, it is 3. Okay, this is multiplied by 3. So, the answer will be 9 over here. Like that, there is another expression which is nothing but 4, 13, 5 slash and plus. So, how to evaluate this? First, we will evaluate this. So, it is 13 by 5. So, 13 by 5 is, it is 2. So, it is 4, 2 plus. So, 4 plus 2, it is 4 plus 2, it becomes 6. So, answer is 6 over here. Okay. And there is a third big expression is given. Let us solve it and check whether the answer is 22 or not. So, first let us solve this manually and then we will start doing a problem. Okay. Then we will write down the code for this. Now, whenever a big expression is given to you, how to solve this problem? So, for solving this problem, we will make a table and first we write down the symbols, followed by we'll write down the operands. It is OP1, then we'll write down OP2. Okay, and the result of the operands we'll mention here, and we will do this with the help of a stack. Now, what are the strings that is given? So, we'll consider these strings as integers. So, it is 10, 6, 9, 3, then plus, then minus 11, then star, then slash, then again star, then 17, plus 5 and plus. Last there is a plus over here. Okay. Okay. At the end we have a plus over here. Now, how to start? The first symbol is an operand. So, the rule says that if it is an operand, then simply push it onto the stack. So, we'll just note down, we'll make a stack over here and we are inserting 10 over here. So, I'm writing here 10. Then, the second operand is, second value is, symbol is also an operand. So, we'll push it onto the stack. So, it is 10, 6. Then, 9 is also an operand. So, we'll write 10, 6, 9. Okay. Now the last one is also an operand. It is 3. So we'll write 10, 6, 9, 3. So you have to write like this. Then we have plus operator. So whenever there is a plus operator, top two symbols we have to pop it and we have to keep it in the operands, and then you have to apply the plus operator and we have to evaluate the result. So 3 comes here and 9 comes here. Okay. So this one, it will come here and 9 will go there. Okay. Now, after that, you have to apply the plus operator. 9 plus 3 becomes 12. So, 3 and 9 we have popped it. Now, we have 10, 6, 12. The result again, we have to push it back to the stack. Okay. So, the result is here 12. Right. Now, next comes minus 11. Minus 11 is also an operand. So, simply you have to push it onto the stack. So, we have 10, 6, 12, minus 11. Next comes star. So whenever star comes, so we'll write here 12 here and then minus 11 here. So it becomes minus 132. So the result we have to push it onto the stack. So 12 and minus 11 we have popped it and we have now 10, 6 and minus 32 on the stack. So we have minus 132 on the stack. Right. Next comes your division operator. So for division operator, we'll write here minus 132 and we'll write here 6. Okay. So 6 and minus 132, we have to pop it. Now, what is left in the stack? 10. And find out the result. 6 divided by 132 becomes 0. Okay. So whenever you are doing integer division, 6 divided by minus 132 is 0. So we'll push 0 onto the stack. So now stack contains 0. Right. Then we have a star operator. So we will have write here 0. We'll write here 10. So 10 into 0 becomes 0. Now your stack contains 0. So my stack contains now 0. Next, 17 has come. So we'll push it onto the stack. So 0, 17. So we'll write down another stack over here for better clarification. So now it is like this. 0 and 17 are there on the stack. Next comes plus. So we'll write down 17 here. Here plus, sorry, here 0. So 0 plus 17 becomes 17. So 17 is there on the stack. We have popped it. We have done addition. Now 17 is there on my bottom of the stack. Okay. Next comes plus. So 17, 5 we will write it down. 5 will write it down. And then plus operator has come. So it is 5. It is 17. 17 plus 5 is 22. And finally 22 is there on the stack. So after addition, 22 is there in the stack, which is the result of this expression. So through this, hope you have understood how to evaluate a postfix expression or reverse Wallis notation. Now, once you understand the evaluation process, it is easy to code it. Now let us see the coding of this problem using Python. Now, whenever you write a reverse Wallis notation, so here we have a function called evaluate RPN. RPN stands for reverse Wallis notation. And we are giving the input as my token. Okay. Now, if you will see this example, you can take anything 2, 1 plus 3 star. We'll take the first test case. Now, we'll take the token as 2, 1 plus 3 star. This is our tokens. Okay. So the token is given in the form of list of strings. Right. Now, the purpose is whenever the operands are given in the form of strings, we have to convert it into integer and then we'll store it into a stack and then we'll apply the operators on it to get the result. Right. So initially we have taken a stack which is initially a list or which is an empty list. So we'll take a stack like this. So this is called our stack. Now we will iterate over the tokens because tokens is also a list, and we will check what each symbol represents. Now if the for operator in tokens, what is the first operator? My first operator is 2, which is nothing but an operand. So if it is an operand, what we will do? We are checking it through the if condition. Is it a plus symbol? Is it a minus symbol? Is it a multiplication symbol or division symbol? Because in the program they have told to consider only these 4 as the valid operators. So 2 is not any one of these operators. So directly we will move on to the else part. And what we will do? We will convert this into integer of this string, which will give you integer 2, and we'll push it onto the stack. So what we are writing? We are converting the operand into integer, then you are appending into the stack. So now stack contains 2. Okay. Consider this second operand in the tokens. So in the second one, we have 1, which is also an operand, which is none of these operators. So directly it will convert into integer. Int of a string is converted into integer. Now it gives you 1. That one you have to push it onto the stack. So here again we are pushing onto the stack. Okay. Next symbol we have is a plus operator. So if it is a plus operator, what you have to do? Top 2 symbols you have to pop it. Okay. Suppose 1 I have popped it and storing into a variable b. Okay. And this is into a variable. Second one I am popping and storing into a variable a. Now what we have to do? This is for that we have written a comma b is equal to stack up pop 2 times we have written. So 2 times pop operations you have to do. Store it the values into 2 different variables, and then you do addition b plus a, you do it, and then append it onto the stack. So for doing b plus a, what you will do? So b plus a is 1 plus 2 is 3. So we'll append it onto the stack. So you can see that stack dot append of b plus a. Right. Now next symbol is again 3. 3 is an operand. So we have to store it into the stack. So we'll push it onto the stack. We'll convert into integer and we'll push it onto the stack. Now it is like this. And the last symbol is star operator. So star operator means our operator is star. Then top 2 symbols we have to pop it. So here again we'll write b is equal to 3 and a is equal to also 3. Top 2 symbols we have popped it. Okay, now we have to do b star a. B star a is 3 into 3 becomes 9. So that we have to append it onto the stack. So you can see over here the code a comma b is equal to stack up pop and stack up pop 2 times popping we are doing. So top 2 symbols we are removing, and then we are doing b star a, which is appended to the stack again. So finally all my symbols are over and the final result 9 is there in my stack. So what I am returning? I am returning stack up pop. So the result which is there in the stack, we are popping it and returning. Okay. So I hope this code is understood, which is written in Python, that how we will evaluate the reverse policy notation. And for executing this program, you can write down simply the driver code, create an object of solution class, and call the method reverse policy notation by passing the input tokens. I hope this question is understood. Now, let us move on to the next question. Using the applications of stack, let us go for the second question. Now, in this question, you have to design a stack that supports push, pop, top, and retrieving the minimum element in constant time. So this problem is mean stack problem. Now you have to implement mean stack as a class, and where mean stack initializes the stack object. That means you have to create a stack. Then second operation that you have to write, the method you have to write is called a push method, where you can push an element or value onto the stack. Then you have pop method, which will remove the top element from the stack. Then you have top element, which will display the topmost element in the stack. And similarly, you have a getMin method, which retrieves the minimum element in the stack always. Right? And it has been given that you must implement the solution with order of 1 time complexity for each function. Now, in a normal stack, whenever you are implementing stack, the valid push pop operations takes order of 1 time complexity. With the same order of 1 time complexity, we can implement these 4 operations. So what are those 4 operations given? That you have to write a push function to push a value. You have to write a pop function to remove a value from the stack. Then you have to write down a top function to display the value from the stack. And you have to write down getMin function to retrieve the minimum value from the top of the stack. Okay, these are the 4 operations. Now, this problem, main stack problem, can be solved using 2 ways. One is you can take a single stack and you can implement all these 4 operations. Otherwise, you can take 2 stacks. One is the regular normal stack and another one we call it as mean stack, and we can implement the operations. So in this program, that is in this problem, I am going to take 2 different stacks so that the understanding of the problem will be easier for you. So let us take 2 different stacks over here. Now, one is my regular stack where I will do the push pop operations, everything. And I will take another stack called mean stack where the mean stack will always contain the minimum value at the top of the stack. Okay. Now, let us understand the test case through this 2 stacks. Okay. Now, what is the input given? That you have to initialize a mean stack. Then 2 times you have to do push operation. 3 times you have to do push operation. Then after that, you have to get the minimum element. So, always you will do the minimum element, you will get it from the mean stack. Okay. Fine. Then you have to do 1 pop operation, 1 top operation. Again, you have to get the minimum element. This is the sequence of operations you have to apply on the stack. Right. Now, first, let us understand. We have initialized a stack here, mean stack here, which is initially empty. Then 3 times push operation. What is the first value that we are going to push? First value we are going to push is -2. So, let us push the first value to the regular stack. So, -2 we have pushed it. Now, as there is only one element, so what the mean stack will contain? The purpose of mean stack is to hold the minimum element at the top of the stack. As there is only one element, that element is the minimum element. So, we will push the minimum element onto the mean stack also. Next, we have to push 0. So, in the regular stack, we will push 0. So, whenever the element is 0, new element, what will be the value in the mean stack? So, what we will do, we will compare. We will compare the element, the incoming element is 0, what is pushed onto the stack, and what mean stack contains. So, top of the mean stack contains -2 and 0. So, 0 is bigger than -2. That's why at present, I am not going to change the mean stack. It is the minimum element only. Next is push -3. So, let me push it onto the stack. So, now -3 is pushed onto the stack. Now, again, I will compare the new element -3 with the mean stack element. Now, you can see that the incoming element -3 is smaller than your -2. That's why the mean stack, at the top of the mean stack, I will also push -3 because it indicates always that the mean stack contains the minimum element. Right? Now, after 3 times push operation is over, next operation is to get min. Now, whenever I want to retrieve the minimum element, I need not touch my regular stack. I'll retrieve the minimum element from the mean stack. Okay. So, from the mean stack, 3 is retrieved. So, minimum element is -3. You can see that written -3. Okay. Next operation is pop. So, whenever you will do a pop operation, what you will do? The topmost element will be retrieved. So, here -3 will be removed from the top of the stack. Right. Next is means, that is stack of top. That means print the topmost element. So what is the topmost element? That is 0. So 0 is printed because minus 3 is already popped. So now 0 is the topmost element. So mean stack of top is nothing but 0. Right. Now again get mean. So whenever again get mean is there, you have to ask the minimum element. You have to get the minimum element from the mean stack. So here already minus 3 is removed. Now the next minimum element is minus 2. Okay. So with this, all the operations of the mean stack, we have done it. So here, through the minimum stack, we have pushed 3 values. Then we have identified the minimum element, then pop operation, top, then again get min. So these are the sequence of operations that we have performed. Right? So this problem, as I told, can be solved using 2 ways. With a single stack you can do. With 2 different stacks, it is easier to do. So here I am going to show you the code with 2 different stacks. One is the regular stack, one is the mean stack. Now let us see how to solve the problem. Now let us note down the test case. Okay. Now what are the elements we have to push? So the elements are minus 2, 0, minus 3. Okay. These 3 elements. So let me write it down. Push of minus 2 I have to do. Then I have to do push up 0. Then I have to do push up minus 3. Then I have to do get mean once. Then I have to do pop operation. Then I have to print the topmost element. Then again I have to do get mean. This is the sequence of operations you have to perform. Now let us understand. So we have taken a class called main stack and we are initializing 2 different stacks. One is called main stack and one is called main stack. So these 2 stacks are initially empty. So let us understand like this. So this is my main stack and this is my mean stack. So I am initializing 2 different stacks. Okay, right. Now whenever I have to push a value from the into the stack, so I am passing a value which is an integer onto the stack, and what I will do, I'll simply call, because stack is a list over here, so main stack dot append of that value. So minus 2 is appended to the main stack. Okay, now as soon as one value is appended to the main stack, I need to check in the main stack whether is there any value which is less than that or less than that is available. Otherwise, I'll push. So as this is the first time push operation I have done, so what I'm checking, if not self of mean stack, means if mean stack is not having any elements or the value which you have pushed is less than the top of the mean stack. This is called the top element in the mean stack. If it is less, then the value you have to append it to the mean stack also. So out of these two conditions which is separated by OR, if any one condition is true, then the if condition is true. So here if not self of mean stack means mean stack is not having any values. Yes, it is not having any values. So first time you have done a push operation into the main stack. Then what we will do? We'll push this element, we'll append this element into the main stack also. So main stack dot append of that value, we did it. Right? Second, next we'll do once more push operation has come. So second time push up 0. So here value is 0 here. So first you append it to main stack. So main stack dot append of 0, we did it. Right? Next what we will do? If not self dot mean stack, means mean stack is not having any values. No, it is having values. Then we'll check the second condition. So what is the incoming value? Incoming value is 0. Is it less than equal to the value at the top of the mean stack? What is the top of the mean stack? It is minus 2. 0 is less than that? No. So we are not going to append the value 0 onto the mean stack. Hope it is clear? Okay. Now next what we will do? Next, what is your incoming operation? Next is push operation. What is the value? It is minus 3. Okay. Now first you append it to main stack. So minus 3 is appended here. Now if not self dot mean stack. mean stack is not having any values? No, it is having values. Now, the incoming value minus 3, is it less than equal to the top of the mean stack? Yes. So, minus 3 is less than is equal to minus 2. So, if it is less, then you append that new value onto the stack. So, minus 3 also it is appended to this. Okay. Now, so the 3 times push operations you have done. Now, get min function you have to write. So, how will you write? Definition get min. Okay. Now, nothing you have to pass. So, we can simply write self. Right. Okay. Now, for getting the minimum element, always you should get it from the top of the stack. So, what I will write? I'll simply write return self dot mean stack of minus 1. So, this is the minimum element from the main stack that will be retrieved. Okay. Next operation is, which is nothing but here 3. Minus 3 is the minimum element. We have got it. Next element is pop. So, what is pop? So, pop will remove an element from the top of the stack. So, what we will do? Main stack of pop we have done and we have popped it. Now, whenever you are popping an element, you check whether that element is there in the main stack also. If it is there, that also you have to pop it. Okay. If that element is not there in the main stack, if it is popped, then you have to pop it from the main stack also. So you do main stack dot pop also. Right. Next is called top. Get the topmost element. So just it will display the topmost element. It will not remove the top element from the stack. Okay. So what do you have to do? So self dot main stack of minus 1. So the topmost element is how much? It is minus 2. It is 0. 0 is simply displayed over here. Okay. So finally, once more get min operation is there. So get return mean stack of minus 1. That means the topmost element will be displayed. So topmost element is minus 2. Already minus 3 was displayed. Now minus 2 will be displayed. So with this, we have understood how to solve this mean stack problem using stack. Hope everybody understood how to solve this problem. Now, let us move on to another problem, that implementing queue using stacks. Okay. Now, basically, a queue is a linear data structure where there are two basic operations. One is called NQ and DQ. So, NQ is nothing but inserting an element into the queue, and DQ is nothing but deleting an element from the queue. Okay. And every queue has two ends. One is called rear end, one is called front end. So, the elements are removed from the front end and new elements are added or inserted from the back end or rear end. Okay. Now, the operations of a linear queue, if you want to implement, then how many stacks we need? We need actually 2 stacks, we will need it. Okay. Now, let us see how to implement a queue using stack concept. That means we will write down the operations of push pop, but it should work like a queue. Right. Let us understand this question first. Implement a first in first out or FIFO queue using 2 stacks. So a queue can be implemented using 2 stacks. The implemented queue should support all the functions of a normal queue. What are the operations of a normal queue? That is how to push an element, how to pop an element, how to peek an element, and how to check whether the queue is empty or not. Okay. Now, here you have to implement a myQueue class where push of X, pushing an element onto the back of the queue, because the elements are inserted always from the back end, right? Pop removes the element from the front of the queue. So through push pop functions of stack, we are implementing queue operations over here. Next, peek. This peek operation returns the element from the front of the queue. Okay, and boolean empty returns true if the queue is empty, otherwise false. So, if the queue is empty, it returns true, otherwise it returns false. Okay, now there is a note over here. You must use only standard operations of a stack. Okay, which means only push operation, push to top, peek or pop from top, size, and empty operations are valid. Okay, that means you have to use the basic operations of stack only to implement queue. Right. Now, depending upon your language, the stack may not be supported natively. You may simulate a stack using a list or a DQ as long as you use only stack standard operations. So they have told that we are simulating a stack concept. So in Python, you can simulate it through a list or DQ. So I'm going to use a list concept here to simulate the stack operations for queue, stack concepts for queue operations. Right. If you look at the test case, what are the operations given? You have to initialize a MyQ. Fine. You have to create a MyQ class and 2 times push operation you have to do. That means 2 elements you have to push from the back end, from the back of the queue. Then you have to peek. Okay. Peek is nothing but it will return the element from the front of the queue. Then pop will remove the element from the front of the queue and empty will check whether the queue is empty or not. Okay, so what is the order? You can see 2 elements are pushed. So first we are pushing one element, 1. So if I'll see, this is my queue. So one element I am pushing onto the queue. So that is 1. So 1 is pushed. Then 2 I am pushing. So 2 is pushed. So this is my rear end and this is my front end. Okay. Right. Now, whenever you are doing peek operation, it returns the element from the front of the queue. So, what is the front of the queue? It is 1. So, it will return 1. Now, whenever you do a pop operation, also it will return 1 because it is not permanently in peek, it will not remove it. It will just return the element. Okay. In pop, it will remove it permanently. So, it will show 1. So, what is left in the front now? Front, we have only 2. Right. Okay. Now, you are checking last operation is empty. Whether the queue is empty? No, it is returning false because one element is still there in the queue. Right. Now, let us understand the code of this problem. Now, this program can be implemented in 2 ways. Okay. One is using the concept of linked list. I can implement the queue using stack. Otherwise, normally using the concept of list, I can implement. Okay. So DQ also can be taken. So in this case, I am taking only a list to implement the queue operation. Now, write down the class as myQ and initialize a stack. Okay. So here what is a stack? Stack is a list which is an empty list. Now, what is the test case given? Test case is given as 1, 2. 2 times push, peek, pop and empty. So 2 times push operation you have to do push of 1, push of 2. Then you have to do 1 time peek operation. Then you have to do pop operation. Then you have to do empty. So this is the order of the operations you have to perform for a queue. Now if you will talk about this is a queue. This is my queue class. Right. Now I will do first operation push of 1. Okay. Now from the rear end I have to push. So which will be supported in stack through append function. So what I am doing? So x is what? 1 first time. So stack dot append of x. Append will add the element at the end. So initially my queue is empty. One element is appended at the end. So this is 1 here. Right. Second time you do push operation, then 2 will be appended. So it will be like this. So the append function in stack will help you to add the element at the end of the queue. Next we will do a peek operation. Now peek operation only will return the element from the front of the queue, but it is not going to delete it permanently. Okay. So what I am writing? Stack of pop of 0th element, it is returning. Okay. Now, sorry, peek, it is displaying only the stack of 0. So displaying means only 1 is displayed here. Right. Now, whenever you do a pop should be done from the front side. So Normally pop, whenever you will write pop and pop of index, there are two functions in stack in Python. Pop will remove the element from the top of the stack always. Okay. Now pop with index will retrieve the desired element from the particular index. So here I want the element should be removed from the top of the stack, from the front of the queue. So I have to write pop of 0. So 0th element, which is nothing but the front element of the queue, will be removed. So 1 will be the answer here. In peak, it is only displaying. Okay, fine. Now, what is left in the queue? Only one more element is still there. Now, I am checking whether length of the stack is equal to 0. If length of the stack is equal to 0, then the queue is empty. But here, length of the stack is not 0, it is 1. So, one element is left. So, it will return the Boolean value false. Okay, so this way it can be implemented. Same thing if you want to write a linked list concept also. Through linked list concept, you can implement all the operations of queue using a stack concept. Thank you so much. In this video, we have learned the applications of stack by solving various problems. Hope this video you have understood the concept of stack and how to use it in different applications. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.